Using a graphing utility like desmos.com, we can graph polar curves just by typing in something like r equals 3 minus 3 times the sine of theta, and I'll type THET. As soon as I type A, it'll change to the symbol theta, and we see here the cardioid that we saw in a previous video. Now that's straightforward enough because the default parameters for theta, that is 0 to 2 pi, give us the entire curve. We're going to look at an exercise for which that's not necessarily the case. We're going to use a graphing utility to graph the polar curve r equals 2 plus the cosine of 9 theta over 4. This does not fit one of our known usual curves here. We're instructed to use a theta interval that shows the entire curve. The cosine function is periodic. So what we're looking for is a value for n for which the cosine of 9 theta over 4 is equal to the cosine of 9 theta plus 2n pi over 4. This 2n pi is coming about because theta plus 2n pi is coterminal to theta for any integer value of n. Distributing inside the argument, we get the cosine of 9 theta plus 18n pi all over 4, which can be rewritten as the cosine of 9 theta over 4 plus 9n pi over 2, reducing 18 over 4 there. So what we see is that 9n pi over 2 must be a multiple of 2 pi. So that whatever 9 theta over 4 is, I'm adding 2 pi to end up with that coterminal angle. So let's unpack that a little bit. 9n pi over 2 has to be a multiple of 2 pi. What if n is equal to 1? Then we have 9 pi over 2, not a multiple of 2 pi. N equals 2. Then we end up with 9 pi, but that is not a multiple of 2 pi. So neither of those is any good. How about n is equal to 3? I think you know that's not going to work. We're going to get 27 pi over 2, no good. And n equals 4, I think is going to be our magic number here. For n equals 4, we end up with 18 pi. 18 pi is a multiple of 2 pi. In fact, 18 pi is 2 pi times 9. Folks, we don't really care about the 9. What we do care about is that n is 4. Going back up here, we're concerned that n is 4, and we want to put that here where we saw the 2n pi. So if n is 4, considering this 2n pi, we can say that theta has to go from 0 to 8 pi. That's 2n pi for n equals 4. Now let's go back to Desmos. Get rid of this one. And we're going to enter r equals 2 plus the cosine of 9 theta over 4. And notice that Desmos automatically gives us 0 to 8 pi. This is the entire picture. And if it hadn't given us 0 to 8 pi, then we'd know what to put in there. But now you can see where Desmos is getting that from.